Hello. Hello, good evening. Welcome to CS492, Section G, Foundation and Future of Virtual Reality, Artificial Intelligence, and Massively Multi-User Online Role-Playing Games. As usual, I take your agreement to recording this session from KLMS. And today we're continuing the first part about virtual reality. So continuing the philosophical aspects and the simulation hypothesis, today is the first of a two-session chapter, namely about technologies, history, survey, and classification. So that being said, without further ado, let me pass on the microphone, the virtual microphone, to Farhadiba. And yeah, there you go.
Thank you. All right. First of all, can everyone see my screen? Works. All right. Okay, fine. Awesome. Yeah, then hi everyone to today's session about virtual reality technologies, as Professor Ziegler has already said. Let me just introduce myself to you guys. I'm Farhadiba. I'm an exchange student from Germany. I study at RWTH Aachen University. Don't know if any of you know that university. And I'm a master's student. So my interest in computer science lies in human-computer interaction, which you will probably also kind of see in some content of our upcoming content. So let me show you what we guys will be talking about today, and then again, continuing on Thursday. So first of all, these are the contents for today. So we will start off with an introduction to what virtual reality is. And in this regard, we will also talk about the idea of the perfect virtual reality. And I will introduce to you some definitions. Then we will proceed with some keywords to remember in respect to virtual reality. And here I will talk about the 3 I's for virtual reality design. After that, I will take you guys back to 1956 for a short history introduction. I know that these can sometimes be a little tiring, so I beg you guys to just stay with me. We will get through that. I'll try to make it not too tiring. And then again, we will finalize everything with the classifications today. I will introduce one possible way to classify virtual reality technologies and also talk about the reality-virtuality continuum. This is what I'm planning to do today. And then on Thursday, And then on Thursday, we will continue with virtual reality methods, followed by application areas for virtual reality. And then, as I said, because I'm kind of interested in the human-computer interaction part, I thought it might be interesting to also look into interaction in virtual reality, especially locomotion techniques in virtual reality. And then we will conclude everything with current challenges that virtual reality is facing. So without further ado, let us dive into the question, what is virtual reality? So I thought we might start this off with maybe an anime that maybe some of you guys know, some don't know, I don't know. It is called Sword Art Online. And I thought it's a good way to introduce the perfect virtual reality, so to say. So what this anime basically is about is that a VR MMORPG is released, and it can be accessed through a helmet, a nerve gear, as we also know from virtual reality. But this nerve gear is so advanced that it actually stimulates all of the 5 user senses that we have. So it creates this perfect virtual reality, which means that you basically fully immerse into this virtual world that you are not even aware of where your actual body currently lies, because you just feel that you're living in this virtual world. And the story kind of goes that you have this steel castle, as you see in the background there. I think it's called Eingrad, and it has 100 floors, and each floor consists of different monsters which you have to beat to level up and gain expertise levels. And what happens in the story kind of is that on the day the game is released, there's kind of a twist in the story because all the gamers who log in are unable to log out. And then the game developer appears and tells them, yeah, guys, you are kind of stuck here. So you can only leave this world if you're able to beat all of the 100 floors. And one thing about the story is that if any of the characters dies within the virtual reality, they also die in the real world. And the same goes for if the helmet in the reality is removed forcibly from them, they will also die. So I found it pretty interesting because the idea kind of resembles what a perfect virtual reality from technological perspective, at least, would kind of imply. And there is a very famous quote, which also kind of sums this all up, which is by Ivan Sutherland. And he is talking about the ultimate display, which also kind of refers to the perfect virtual reality. So what he says is the ultimate display would, of course, be a room in which the computer can control the existence of matter. A chair displayed in such a room would be good enough to sit in. Handcuffs displayed in such a room would be confining, and a bullet displayed in such a room would be fatal. With appropriate programming, such a display could literally be the wonderland into which Alice walked. So you see, he also says that in a perfect virtual reality or an ultimate display, if you would die in this virtual world, you would actually be supposed to die in the real world as well. This is what perfect virtual reality kind of means. But we can say that gladly, we're still kind of far off of that. But technology is evolving, so who knows if you might end up there at some point. But now let's have a look what virtual reality is as we know it. And first of all, let's start with the etymology of the word virtual reality. So virtual reality consists of the subwords virtual and reality. Virtual thereby means to have the effect of being such without actually being such. And reality basically means the property of being real. And with real, we mean to have concrete existence. So if we just like simply combine these two words, we get that virtual reality means to have the effect of concrete existence without actually having concrete existence. And there are some further definitions which kind of round this all up. The first definition is virtual reality is a simulated 3D environment that enables users to explore and interact with a virtual surrounding in a way that approximates reality as it is perceived through the user's senses. Another definition is virtual reality is the use of computer technology to create the effect of an interactive three-dimensional world in which the objects have a sense of spatial presence. So if we have a look at these definitions, we see that there are some key aspects that are important when we talk about virtual reality, which is the three-dimensionality we have in the virtual world, that you're able to explore and interact with the environment that is provided. That it kind of stimulates a lot of senses you have, that you need some computational power and good computer technology, and that even presence plays an important role. And with that, we have already completed the first chapter for today. So we have had a look at the perfect virtual reality and some definitions. So we can now continue with the keywords and that also like are important for virtual reality. We kind of already started off with that a little in the definition. And for that, I will share to you the 3 I's for designing virtual reality. And the 3 I's consist of immersion, interaction, and imagination. In the following, I will talk about each of these bubbles or I's a little closer and provide some more context. So let us start with the immersion. So what is immersion? Immersion describes the technical multimodal abilities for the virtual reality system, tricking the user that he or she feels being somewhere else. In the context of immersion, 2 other keywords play also an important role, which are presence and orientation. When we talk about presence, we mean that presence describes to which extent the user of a virtual reality develops a sense of being in the virtual environment. That means it's the subjective perception of being physically present in a non-physical world. So while immersion generally talks about the technological perspective of how technology allows us to kind of feel being somewhere else, or immersing in somewhere else. Presence talks more about the subjective or human level, that you personally feel you are in a virtual world right now. And also in virtual reality, orientation plays an important role, which describes a person's awareness of time, place, and person. So the second I of, let's call it the 3I framework, is interaction. And interaction refers to the user's degree of maneuverability of objects in the simulated environment and the natural degree of feedback from the real environment. When talking about interaction, there are two different forms of interaction. You can have 3 degrees of freedom interaction, or you can have 6 degrees of freedom interaction. So first of all, let's talk about 3 degrees of freedom interaction. So when we talk about 3 degrees of freedom, it means that a viewer can basically have a 360-degree view when using this VR headset. But what he or she cannot do is actually physically move around the world. So you see it here, the person is kind of static and can move the head around in every direction, but cannot actually move. So this is what the 3 degrees of freedom regarding the rotation provide. This is effective for static environments. So if you only need choice selection and don't actually need to physically move. So if you have organizations that look for giving learners an all-encompassing view of the real environment with authentic human interaction, that would be an option, especially because it's good suited for like soft skill training. So if you have learners who would like to focus on the experience as a spectator, or just like has tasks where they only need to observe situations from different perspectives, this would be a good way to go. The other form of interaction you could use is 6 degrees of interaction. So in 6 degrees of interaction, as the name kind of already suggests, you have even more flexibility and even more ways to interact. So you have the 3 degrees of interaction, you can have the 360-degree view, but further you can now also physically move around the world. So you can go front, back, and everything. But what you can also do in 6 degrees of freedom is that you can directly interact with the virtual environment if that is given. So if you would have the opportunity or like haptic gloves or anything, this is also given in 6 degrees of freedom, which is not given in 3 degrees of freedom. But because it allows you to interact to this extent, it obviously also requires some computational power, which needs to be given to process the information, and also the input from additional accessories like gloves or helmets or anything. And 6 degrees of freedom is especially well suited for tasks which require you to physically move around. So it would be good for technical skill training, for instance, where learners will feel like they're in their actual work environment, interacting with real life objects, and could perform complex tasks. And the last one is imagination. So imagination refers to human imagination that allows the transfer from capabilities into the virtual world. So basically, it means that we are able to let ourselves be fooled that the virtual environment is indeed real, so that we have the possibility to even imagine something like that. And in this form of imagination, 3 illusions are, hang on. Also important. And the 3 illusions are place illusion, plausibility illusion, and embodiment illusion. So let's start with place illusion. What is place illusion? Place illusion basically works on producing an effect or a feeling that the person has actually been transported somewhere else. And for place illusion, there are 3 aspects which you should keep in mind. So the first is the quality of the display. So you can imagine that if you would be in a virtual reality where the display quality is pretty low or bad, you would instantly kind of know that you're somewhere else. So it doesn't really work that well if you do not have a good resolution, at least. Then the second thing is the position and rotation training. So you want the tracking to be in real time, so that again it feels more real, and the illusion is kind of more supported by that. And finally, you also want to use external hardware to stimulate all the senses that are possible, because the more senses you can stimulate, the better it is for you in the end, because you can create a more real illusion in that sense. And then we have the plausibility illusion. And the plausibility illusion works on the principle of creating a plausible environment that we can believe to be real. And all the aspects which I just named for the place illusion also apply to the plausibility illusion. The main difference between the place and the plausibility illusion basically is that if the plausibility illusion kind of gets broken or kind of gets violated, it is basically impossible to recover from that. Whereas for the place illusion, you could maybe overlook some of the bad resolution or something. So let me give you some example about the plausibility illusion. The first thing is what you should keep in mind, that the environment should respond in a realistic way. So imagine you have some kind of game where you run around and then you have some other person or avatar in your virtual environment, and you can basically just run through them as if they were ghosts. So basically when that happens, you know, okay, this cannot be real. And once you have established that fact, you cannot go back. So you should, yeah, you should make sure that something like that does not happen. You actually simulate stuff which is also real to make the virtual environment seem as plausible as possible. The second thing is objects that keep repeating themselves. So if you have an avatar which is sitting in a park and you have a bird or something which hops over a puddle, for instance. So you have a little bird that hops over a puddle and then flies away. And then comes another bird that hops over the puddle and then flies away. And that just keeps repeating itself exactly as it started. And also you'll kind of know, okay, there's no, like not every bird comes flying in the same intervals and jumps like the same way off. So this also cannot be plausible. So these are things that kind of could break this plausibility illusion, which you also should keep in mind when designing for virtual reality. And the last thing is the embodiment illusion, where while the first two illusions focus more on the virtual environment itself, the embodiment illusion works more on making the... Okay, someone is talking. I think someone's not muted. Never mind. Making the user believe that the body they have in the virtual world actually belongs to them. So again, here also the position and rotation, position and rotation tracking is important.
Could everybody turn off the microphone except Farhadiba?
That would be awesome. Thanks. Yeah, so the embodiment illusion, as I said, also requires you to have good position and rotation tracking, because you want it to be in real time and you want to have a lot of your user senses at rest so that you actually can believe your virtual body to be real. And that already were the three eyes of the virtual reality. So now we're moving to the, let's say, largest part of this presentation, which is the history part. Let me just give you a couple of comments about the timeline you're going to be seeing. So I kind of compared three different virtual reality timelines, and then decided to kind of create my own timeline, what I thought would be interesting for this presentation. So let's start with 1956. So my timeline starts with Sensorama. Sensorama was created by the cinematographer Morten Heilig, and it is considered more or less as the first virtual reality machine. It shows a large booth which can fit up to 4 people at the same time in it. And it has combined multiple technologies to simulate all of the user senses. So there was a combined full color 3D video, audio, vibrations, smell, and atmospheric effects such as wind. So this was done using sound producers, a vibrating chair, speakers, and stereoscopic 3D screens. And Morten Heilig at that time called it the cinema of the future, because he wanted his viewers to fully immerse in the movies they are watching. So there were 6 root films created for this booth. Maybe you can compare it to what we know as 4-dimension movie watching nowadays. So if you've gone to some, I don't know, amusement park or something, They sometimes have these kind of movies where you get wet, like there's sparkling water and everything. So the idea kind of already started in 1956. Then we continue with 1960. So 4 years later, again, Martin Haley made the first attempt to kind of create a head-mounted display. This head-mounted display did not have motion tracking yet, but it provided stereoscopic 3D images with wide vision and stereo sound. But then after 8 years, now Ivan Sutherland, which you hopefully still remember from the Ultimate display, then actually established the first virtual reality head-mounted display. And it was called the Sword of Damocles. He was actually working on that together with his lab student, Rob Sproul. And what it is, it's a head-mounted display connected to a computer rather than a camera. And it was quite primitive at that time because it could only show simple virtual wireframe shapes. And these 3D models changed perspective when the user started moving their head due to the tracking system. But it was never developed past the lab project phase because it was very heavy. So you can see in this picture that you have these metal pipes that are attached to the ceiling, and then you have this large spider kind of structure, which is then connected to your helmet. So you could not really move around. It wasn't very flexible. Kind of worked, but it was very primitive. 7 years later, the video place was created by Marian Kruger. And the video place is the first interactive virtual reality platform. So it was displayed at Milwaukee Art Center at that time, and it used computer graphics, projectors, video cameras, video displays, and position sensing technology. But what it didn't use were goggles or any head-mounted display. So basically, it was just a dark room where you had these projections, and those projections showed different stuff. Like here you see, I don't know, some city. And then you had your own silhouettes, and you could kind of interact with the scenes you were seeing on the projections through your shadows, which were projected on that. So that was the first kind of interaction with some displays. In 1978, we continue with the Aspen Movie Map, which was developed, created by the MIT. And basically, users could virtually wander around the streets of Aspen in Colorado. So it's comparable to what we know as Google Street View nowadays. And there were 3 modes provided, I think like summer, winter, or autumn, which you could select. And it was created using photographs from a car driving through the city. So there were no head-mounted displays, but it did use the first-person interactivity, and it kind of suggested for virtual reality that virtual reality could transport people to other places as well. And 1 year later, virtual reality also reached the military. So the head tracker in the head-mounted display there followed the pilot's eye movements to match computer-generated images. And this helmet was called the Vital Helmet, and it was basically only used for military training. With that, we jump forward to 1982. In 1982, there was WCAS and Tron, and Furnace created a working model of a flight simulator, which was called WCAS. It stands for Visually Coupled Airborne Systems Simulator. It was a fully immersive 3-dimensional circumambience of a graphical information superimposed over the real world. Also, what happened in 1982 is Tron. So we were watching a couple of movies, but apparently the first movie depicting virtual reality was released in 1982, and it was Tron. Then, 1985, VPL Research was the first company that was founded by Jaron Lanier and Tom Zimmerman that actually sold virtual reality hardware. So they had a wide range of different stuff, which they offered to the public, including goggles and sensors and head-mounted displays. In 1987, so you see, like we have been talking about virtual reality an entire slide now, but it wasn't until 1987 actually that the term virtual reality was coined. So it was coined by Jaron Lanier, who popularized the term then. He was the founder of VPL Research. Yeah. And also the super cockpit was developed. So Furness, who also worked on the VCAS before in 1982, further worked on another flight simulator called the super cockpit. And the super cockpit was for pilot training, and it was it had computer generated 3D maps, advanced infrared and radar imagery, and the pilot could see and hear in real time. So the helmet's tracking system and sensors allowed the pilot to control the aircraft using gestures, speech, and eye movements. And also in that year, the holodeck had its first appearance in Star Trek: The Next Generation. In 1991, we had the virtual reality first came to the public in a form of entertainment. So in 1991, the Virtuality group launched, I think it was also called Virtuality, which were virtual reality arcade machines where gamers could play in 3D gaming world. So this was the first mass-produced virtual reality entertainment system. And it had virtual reality pod featuring virtual reality headsets and real-time immersive stereoscopic 3D images. So some of these machines could also be networked to provide a multiplayer game. And eventually some of the very popular and known games such as Pac-Man or arcade games might have had such VR versions. 2 years later, Ziegler then first announced to create some functioning virtual reality glasses. So they said they wanted to create glasses which would now also be available to the public. And the headset was meant to be used on arcade games and the Mega Drive console. And it had a visor-like look due to the influence of popular films. And it consisted of you had LCD displays which were placed in the visor, as well as stereo headphones and a sensor for tracking the head movement. However, the glasses were announced, but they never actually really made it to the general public. They claimed that they were afraid that the virtual reality was way too real and that people might get injured, but that is pretty unlikely due to the limited processing power in the end. We've almost reached like in 1995. In 1995, I will introduce the Cave, the Virtual Boy, and some more home VR headsets. The Cave, I don't know if you know it, it's an automated virtual environment. So it's kind of the advanced version of video plays. So in video plays, we have this dark room with some projector screens. In Cave, we have a cubic room now with a lot of projector screens. So yeah, it has these walls, and the walls consist of rear projection screens, and the bottom floor wall can be a down or rear projection screens. And if one of these cubes also have like floor ceiling, it's like a 6 cubic cube or something. Also, what happened in this year is that Nintendo launched its Virtual Boy, and the Virtual Boy console was meant to be played on 3D monochrome video games. It was the first portable console to display 3D graphics, but it also was a commercial failure because it did not provide a lot of colored graphics. It also didn't provide software support, and it wasn't very comfortable to use. But gladly in this year, some other virtual reality headsets were made available to the public. It's 2 more slides. It's getting better. Stay with me, please. So 1997, we're getting there. We have Virtual Vietnam. And so Virtual Vietnam was a research project by Georgia Tech and Emory University. Researchers created virtual reality war-zone scenarios for veterans who were suffering from PTSD. So this kind of virtual reality exposure treatment is actually also further developed and also used nowadays still. Now we're going to do like a 10-year lapse forward to 2007. In 2007, Google Street View, as we know it today, was first introduced. So there you also know it's kind of virtual reality because you have this first-person narrative and you can kind of walk around in this virtual world which resembles our actual world. In 2012, then Oculus Rift, the Oculus Rift campaign started by Lucky, who launched a Kickstarter campaign for this Oculus Rift, and it raised $2.4 million. And after that, 2 years later, Facebook bought Oculus VR company. And this is considered as a defining moment in virtual reality history because several virtual reality hardware releases came straight after that, and it kind of gained momentum in that year. So to name some examples, Google released its cardboard glasses in the same year. Samsung had announced the Samsung Gear virtual reality, and Sony announced that they were working on Project Morpheus, which was a VR headset for the PlayStation 4. In 2015, 1 year later, virtual reality was gaining even more popularity, and it was starting to become widely available to the general public even more. So the Wall Street Journal, for instance, launched a virtual reality roller coaster that followed the ups and downs of the Nasdaq stock market. The BBC created a 360-degree view where you could actually visit a Syrian migration camp. And another example would be that the Washington Post released a virtual reality experience of the Oval Office at the White House Correspondents Association dinner. 1 year later, in 2016, so you have to imagine that so far there are a lot of virtual reality hardware being developed, but the haptic interfaces are still underdeveloped. So most of them have like controllers and everything, but still we're struggling to actually realize the haptic sensors. So in 2016, and then the HTC Vive Stream virtual reality headset was released, which was considered as the first commercial release of a headset with sensor-based tracking, which allowed users to move freely in space. We're coming to the last slide of their history section. So we're in 2017, and in 2017, meanwhile, the first official virtual reality arcade opened in Utah. And less than I kind of got lost there. Yeah, so basically designers recreated a virtual playing field in a physical space equipped with real objects such as wall and torches. So it was a perfect example on how a virtual reality experience could be combined with virtual and actual reality. So to give an example, if a user in the virtual world would walk around and grab a torch, then the torch would actually be positioned, a real torch would be positioned at the same position. So you would actually be grabbing a real torch, and you had heat sensors and everything to kind of also provide this haptic feeling. And yeah, so this made like a unique experience in virtual reality. 1 year later, apparently there was the birth of a virtual reality superhit, and more standalone headsets were introduced. And this virtual reality superhit apparently is Beat Saber. I don't know if you know it, but it's considered as one of the most important virtual reality games of the then upcoming years. And it immediately became a phenomenon in 2018, because less than a month after its release, the game had already sold more than 100,000 copies and generated $2 million revenue. And the concept of this game is that you have two laser swords, and the player basically slices up some cues to the rhythm of electronic music. And the developer really hit the bullseye with this game development, because Beat Saber integrates virtual reality movement into the gaming experience more simply and elegantly than any other game before. But it only worked on virtual reality, so there is no comparable experience for the monitor. And in the same year, also like more, I think the HTC Vive Focus was also released, which was considered as the first self-sufficient virtual reality headset at the end of the year. And it was mainly scored to be used in this in the B2B sector and education. 1 year later, then even more hardware came. So we have the HTC Vive Cosmos, and we have Oculus Quest on Valve Index. So just to shortly talk about like some technical capabilities of these hardwares, HTC Vive Cosmos at that time was considered to have the sharpest display to date and minimal fly screen effect. At the same time, The virtual reality is to come and more mobile. So the integrated cameras take care of the spatial orientation, and there is no need for external tracking anymore in these head-mounted display. The resolution at this time was like 1440 to 1700 pixel with 2 LCD displays and RGB subpixel metrics. Okay, I will not name all the technical details, but yeah, it was getting more advanced. And the second thing is the Oculus Quest. So it was the first version that was released in 2019. It had 2 OLED screens and 1600 to 1440 pixel resolution. And it was supported, but it came with 2 controllers as well, and offered a wireless virtual reality experience. And the last one is the Valve Index, which is considered to be one of the best PC virtual reality headsets on the market. In 2020, as we all painfully remember, the pandemic started. So with the start of the pandemic, a lot changed, as we can still see. I'm holding this presentation online and not offline in person. So a lot of people had to be quarantined. We had the lockdowns, schools closed, people couldn't go to work. So everyone still remembers that. So with that change, it also obviously affected the timeline of virtual reality. So virtual reality kind of tried to meet the need for a virtual meeting application like Zoom or other collaboration apps. So in that year, more than 150 apps for extended reality collaboration appeared in the online database at the end of the year. But still, they weren't very successful, such as like Zoom or any other online meeting tool as we know it was. And then finally, in 2021, Sony also announced the PlayStation Virtual Reality 2 for the PlayStation 5. And with that, we gladly conclude our history session for virtual reality. And I will use the remaining time to talk about the classification and the reality-virtuality continuum. So one way to classify virtual reality is according to its level of immersion. There is non-immersive virtual reality, semi-immersive virtual reality, and fully immersive virtual reality. Non-immersive virtual reality, some might think would not be named as virtual reality. But if we look back at the definition before, just plainly through the etymology, it just means like that you create like being somewhere virtual without actually being there. And that is also given in non-immersive virtual reality because you have this 3D world, which also only applies for games where you have the first person narrative. And you still have some control over the virtual environment with your mouse or your keyboard, but you don't have any direct interaction. So it's still kind of considered as virtual reality. Then we have semi-immersive virtual reality, which gives a focus on the visual 3D aspect of virtual reality. So here you can also use head-mounted displays, but still you would not have any physical movement. So flight simulators, for instance, would fall under the category of semi-immersive virtual reality. And then lastly, we have fully immersive virtual reality, where you have a head-mounted display and you can use data gloves or these treadmills, as you can see in this picture, which allow you like a much more advanced possibilities for interaction in the virtual world, and much more senses are addressed, and you have 6 degrees of freedom. When looking for the classification, some also name augmented reality and collaborative virtual reality as classification forms, which I personally would not put into that classification, but I will still just quickly mention it. So augmented reality is that you have the real world and you basically just overlay virtual content on top of it. And collaborative virtual reality refers to people, allows people to meet in this virtual world from different locations. So basically what I was saying earlier about during the pandemic, that would be something, some virtual reality application that would have come in handy. And lastly, we will talk today about the reality-virtuality continuum to just sum this all up. So I've already kind of suggested that augmented reality for me doesn't totally fit into virtual reality. So What virtuality continuum basically describes is that we have the real environment on one side, which consists solely of the real objects or physical objects as we know it. And then we have the virtual reality as the extreme on the other side, which consists solely of like digital objects. And augmented reality, as I said, basically means that we take this real environment and we just like superimpose virtual content on top of it. Whereas augmented virtuality would be the similar thing which we would do to virtual reality. So we take the virtual world and augment it with real or physical elements, and that would give us the augmented virtuality. And when we talk about mixed reality, we actually just mean the continuum between the augmented reality and the augmented virtuality. So anything in between there, any environment where the real and virtual objects are combined within a single display is considered as mixed reality. Okay, I thought I have one more summary slide there. Never mind. But all right, let me just quickly go back here. So basically, we now finalized the contents for today. We have talked about what virtual reality is, what keywords there were to remember as interaction, immersion, and imagination. We had a brief look at the history of virtual reality, and finally also looked into the classification, how we can classify it according to the level of immersion. And then next week, we will, as I said, okay, this is kind of messed up all across the place, sorry for that, talk about the VR methods. I did not mean to close this. Here. We will talk about the VR methods, applications, and local immersion techniques, as well as the VR challenges on Thursday. Now I'm done.
Thank you and congratulations. Very well. I've learned a lot. These are my favorite lectures where I learn. Right, yes. As with the previous talks, let us first discuss the content. So if somebody has questions or comments, and after that, we talk about feedback, assessing the presentation, providing recommendations for improvements, if there are any. Okay, so first part, questions.
I have a question. What do you think, what is the next innovative technology in VR? Because I know there's many technologies are developed, very well developed in VR technology, such as hand tracking or eye tracking or haptic shoot. So I wonder which one could be more, which one coming soon?
To be honest, it's a little hard for me to answer because I'm not too well into what is coming up. So I'm basically also know what you suggested. So as I said, haptic is very, very important for the virtual reality, and this is still very underdeveloped in the virtual world. So we're going towards like gloves and different, like as I said, hand tracking and everything. So I think that this would be like the first bridge that we should be working on when looking into future research. And I think there are a lot of attempts going into that direction as well, because that is kind of the greatest bridge that we have as we want to address all of the user senses to create this full immersion. Yeah, I'm not sure if that actually answers your question. But I might be able to look into that and maybe find something for Thursday, which is kind of interesting, where the current technology is going.
Yes. So does anybody else want to answer that question? Yes. In that case, let's leave it for Thursday. Okay. No, just kidding. Right, further questions? Now, come on, this was such an inspiring talk. I'm sure you have some ideas or questions or comments.
Oh, can I have some questions?
Sure, yes.
So first of all, I'm so sorry about disturb your presentation at middle of your presentation. And my question is, I saw some picture of your presentation about like the Japanese animation, and in that animation, the people use the VR with very high technology, which is like the sense the human brainwave. And do you think that kinds of technology is possible in the future?
Did you hear the question? Is there some audio problem or is it just me?
I also can hear the voice.
Oh, I've been just going on and I was muted. Okay. No, I'm not hearing him as well. I was saying he was saying something about the Japanese, some Japanese technology, but I'm not quite sure which one he's referring to. That's why. Did you hear my question, or was I just muted and I was just talking to myself all the time? So I basically asked which. Yeah, which technology you were referring to?
In your like a fifth page of your presentation, you come up with like some picture of the animation, and in that animation, because I saw that one, so in the animation they use the VR technology with like they sense the human brainwave, and with that brainwave they made like the VR with that. So in today, just we use like sensor that sense the human's haptic or like that, or eyeballs move. But in that animation, they describe the VR technology like to sense the brainwave. So do you think the kind of technology is possible?
That's a difficult question. I don't know if it's going to be possible to this extent. I mean, we are working towards realizing the best virtual reality possible. And a lot of these things, which I mentioned throughout the history timeline, seemed impossible a couple of years ago as well. So it might even be possible that we get to some sort of this extent. But yeah, I have to admit that I'm not too much into the background technology in there to think about how realistic anything of this could be, but I could. Are you referring to like the dying part, or are you referring to the immersion part in there?
Pardon, I can hear you clearly. So.
I was asking, are you referring to how fully immersed this yeah, this game was, or are you referring to also whether it would be kind of possible to die in reality when you die in virtuality?
I think, sorry if I interrupt, he was mentioning something about brain waves and the fact that I think in the animation they are connected with their brain. He was asking if that was possible, if I remember correctly.
Yeah, I think your comment is right, and I'm sorry for my English is not really good, so I can understand your question well. Sorry.
No, it's fine. Yeah, I have to honestly pass on that question, I guess, because I'm not I personally don't know myself, but I could imagine that technology gets advanced, and maybe someone else is here who knows more about this and could answer something about that. Or what do the other ones think? Maybe I can just pass on the question to the other one. What do you think? Are we going to that direction? Would it be possible to connect our brain to that? Would it be possible to even at some time mimic this dying in virtuality and then dying in the real world?
So the reason why I made this kind of question is that I saw the kind of paper that there's a new technology that sends the brainwave and to read the people how to speak, like with no sensor of the voice, only with the brainwave, they made a sentence that he want to say. That is the purpose of the paper. So I thought that this kind of new technology will be emerge in future. So there's reason why I made the kind of question.
It kind of actually reminds me of this brain movie we were supposed to watch, where we had this, I think it was the first movie, I don't know, where we had this brain extracted and the brain kind of stimulated the body or something. So I mean, the idea exists. The idea is also kind of yeah, mimicked in movies and everything. And if you already read a paper which goes into that direction, I mean, it could be that in a couple of years we will be much more advanced, and even it might be possible to not even need like totally rely on the technology, but also just like purely power that through our brain.
Oh, thank you for answering.
I have a question.
Yeah.
So currently, people are trying to mimic our reality, our three-dimensional space, and moving in our three-dimensional space, replicating that experience in a virtual setting. But I can imagine that there are many more ways to use virtual reality to simulate realities that are very different from our realities, that may not even be three-dimensional, maybe other dimensions or other realities. Have you by any chance come across such considerations or developments?
I tried to look into it. I unfortunately did not find anything very interesting in the regard. And I think the reason for that is because, I mean, as it is still based on computer and technology, we as a human kind of create the input for that. So we as a human kind of need the idea to put it into that. So this is why I think a lot is still simulation, because it results from what we know and what we think, and this is what we can input and then mirror again. So to create something that is that mirrors like different dimensionalities, so far I think we as a person, someone will have to have the idea to remove something like that, and maybe we're at this point not able to imagine something like that yet, to create it for others to imagine. But I'm Not sure. That will just be my explanation or guess why I wasn't able to find something too cool. I mean, the only thing that I just did find is like in educational, we will have an application for that you can use it for like using like the property of this three-dimensionality for like mathematics and computer graphics and stuff, and like creating new forms of learning or teaching through that, which you couldn't do before. But that's the farthest I did find so far.
Thank you.
If I can add something, I think we are also limited by our senses. So like we cannot see 4 dimensions or more. We can only see up to, I would guess, like synthesize some sort of 3 dimension. And like we would be able to simulate something like using maybe haptics in the hands and like seeing at the same time. That would be like some 4th dimension. But we're still stuck with our senses, and since we are only trying to, we cannot yet create senses. I think the other way to like bypass this limitation will to literally create senses, but we are not to the Netgear yet, where like it can actually hook our senses to bypass the signals and sense anything.
Oui, d'accord.
If I can add an example, though, there's one crazy guy that developed Minecraft in 4 dimensions, which is really, really strange and fucked up. But basically, you have kind of a slider that, through movement, lets you see the 4th dimension. I can link the YouTube video if you're interested.
Yes, very interested.
But I think it's a direct message.
Yeah, let me share that with everyone.
And also, I have a question. If you could please go to the slide where the 3 illusions were.
Where the illusions were. Okay,
shown.
give me a second.
Yes.
Yeah.
So this is more of a personal question, actually, because here you define the place illusion, plausibility illusion, and embodiment illusion. But would you consider them to actually be illusion? Because after all, it's yes, it's not a real place. So you trick your mind to be in a physical place, but the actual place kind of exists, but not as we are actually perceiving that. So would that be an illusion, or would it be a representation of something that actually exists, but maybe under another, I don't know, like 1 and 0 code and bits?
I think yeah, okay, I'm not muted. I think it's both, actually, because it's a simulation. It's obviously like, if it is a simulation, it obviously is a representation of something we know. But illusion basically only refers to this. Like, illusion for me is seeing something that is not actually there, I would say. So if you're in you could use the virtuality in your office, and you could have the illusion of being in Paris next to the Eiffel Tower. So you have the illusion of being somewhere, a place which you actually know, but still it's an illusion that is created because you're not actually there. So this is why I also think that illusion fits the description.
Mm-hmm. Okay, thank you.
But you're happy and invited to argue against it.
Yeah, no, I was thinking about illusions such as phantom limb and other kind of embodiment illusions. I mean, there you're tricked to think that you're someone else or something else, or that you have other body parts. And if you're in Paris, technically you're not tricked, like, you know, it's a virtual place. So if you look at the definition of the word illusion, I'm not sure it could really fit, like, if it becomes a popular technology. I don't know if that will be, I don't know, considered as an illusion anymore, but I see your point though, and I kind of agree.
Maybe
Yeah,
that
just look it up. It kind of means an idea or belief that is not true, or something that is not what it seems to be, is an illusion. So I think something that it's not what it seems to be. Yeah, I think it kind of goes into that direction. Like, I understand your point, but for me, simply it just refers to this. Yeah, it's not. How do I say it? Yeah, you can be in Paris and you know it's virtual, but I mean this kind of also refers to this perfect idea of virtual reality. So if you would have the perfect illusion, like for instance an Inception, then you would have a place illusion or like a plausibility illusion or anything, and you wouldn't know because it's that well mirrored that you would just forget that you're not even there. So this is like the illusion you create, but we're far off from that extent of creating such illusions at this moment.
this leads back to our very first talk about the question, what is real after all? If something is simulated so well that it becomes indistinguishable, then why not call this the reality on its own, right? That's why we had the philosophical talks first, because this question really come. Okay, well, yes, thank you very much. And now we move on to the second stage, where you are encouraged to give feedback, both positive and negative. Maybe it's easiest to start with a positive one. So, shoot. Now, come on.
It was very interesting and easy to understand because she uses graphs and pictures. I really like the graph with the history.
I like that graphic in history too, but I hope there is some kind of video too, because it is about virtual reality and it's interactive. So I wanted to see it. But it was good. It was really good.
I also really like the history part because it really gave the sense of how this virtual reality developed throughout time. And every time I hear about this history of VR, I get surprised how long of a history it has. It's not like recent technology going on, but it's something that continued from a very long time ago. It was very interesting to hear about it. And also the classification part was good too. It was very clear, and I've got to like understand what augmented reality and the difference between augmented reality and augmented virtual, what was it? Augmented, right?
Virtuality.
Virtuality. Yeah, it was interesting. Thank you for your presentation today.
Thank you for your feedback.
Yes? More feedback? Yeah, two things that I particularly liked on top of all the things that already have been said is the design of the slides, not the standard design of PowerPoint, and the well-structured talk, right? So there was a clear outline and it was repeated every time. So it was a very, very well-structured talk.